Who is Vishay Specialty Thin Film? Vishay Specialty Thin Film combines the thin film technology and expertise of 3 of the top custom thin film manufacturers in the world. With over 100 years of combined thin film manufacturing experience, over 300 employees worldwide, and over 100,000 feet of manufacturing space, the STF division can support any thin film custom substrate request. Specialty Thin Film supports military, aerospace, industrial, automotive, telecommunications, and medical. STF specializes in specialty thin film products, build-to-print manufacturing services, and thin film wire bondable chip resistors, capacitors, and spiral inductors, offering special manufacturing capabilities, including high-density interconnect, tight tolerance resistor networks, filled and plated vias, sputtering gold tin, thick copper plating, CO2 laser cutouts, air bridges, and sidewall patterning. Our extensive knowledge and capabilities support immediate technical reviews and feedback, as well as quick-turn prototyping. The Specialty Thin Film Division is growing and building the DNA of tech. What can we build for you?
Vishay Specialty Thin Film Division presents the benefits and design rules of thin film metals. Vishay Specialty Thin Film offers sputtered and plated thin film metal options. The different metallizations can be used as adhesion layer, barrier layer, conductor layers, or dielectric layers. The plated metal options STF offers are copper, nickel, and gold. The sputter metal options STF offers are titungsten, titungsten 9010, nickel, gold, any peg gold, chrome, copper, palladium, and platinum. Thin film is deposited in a molecular or atomic process and can reach thinner thicknesses, lines, and traces. Thin film has better performance, low TCR, low noise, and better high-frequency performance. Thick film is a metal powder resin composite that is screen printed. Thick film is generally a reliable solution, less expensive, and used when tight requirements are not critical. For example, a thin film resistor can have a tolerance as low as 0.1%, while the best tolerance in a thick film application is typically 1%. Also, an 0202 case-size thin film resistor can handle 250 milliwatts of power, which is typical of a 1206 SMT component. Vishay STF offers standard metal stack options that are commonly used in custom substrates. Examples include a standard metal stack, like titungsten gold, which is commonly used when devices require assembly at higher temperatures, or a more complicated metal stack like chrome, copper, nickel, gold, which is used in high-power applications. Vishay STF also offers special metallization options. A sputtered 8020 eutectic gold tin solder, which is typically used as a mounting pad for laser diodes. Thick copper plating option, which is used for power handling and thermal management. The ability to deposit gold and aluminum on the same substrate, which can be useful when using gold and aluminum wires in the same assembly and in high temperature applications. And sidewall patterning option, where we can deposit material on 4 sides at a time and allows attachment to the sidewall of the substrate. More information on thin film metals can be found on the Vishay website. Thank you. Vishay Specialty Thin Film Division presents the benefits and design rules of the plated metal technology. The key benefits of plating technology stems from the fact that it is an additive process. Unlike sputtering, where the metals are sputtered onto the plate then etched back to form the circuit lines, plated technology electronically bonds to a thin layer of metal pre-deposited on the substrate and patterned using photoresist masks. This method leads to less time manufacturing and less precious metals being wasted. It also enables more uniform circuit lines, thinner and more flexible circuits, high-density interconnects, and consistent trace definition in electrical and mechanical performance. The plated metal options that Vishay electro-films offers are nickel, copper, and gold, where nickel can be used as a barrier layer with a plated thickness range of 10 to 100 microinches. Gold is used as a conductor layer with a plated thickness of 100 microinches minimum, and copper is used as a conductor layer with a plated thickness of 100 microinches minimum. We also offer high current conductor options with gold with a plated thickness of 300 microinches minimum and copper with a plated thickness of 1000 microinches minimum. Our wide range of photoresist options allow for both thick copper traces for high power lines and selectively plated thinner gold RF lines on the same substrate. Vishay EFI's thick copper plating option is great for power handling and thermal management. The copper plating can be as thick as 4 mils. As the plating thickness increases, the line widths and faces also need to increase because as the thickness increases vertically, it also increases horizontally. The main design rule when designing circuits with plated metals is understanding that the thicker the plated metal, the larger the pattern's lines and spacing must be. This is due to the level of control manufacturers have of the metal growing on the plate. The smallest standard conductor line or space that VFI offers is 1 mil plus or minus 0.2 mils, or for special cases we can reach a half a mil plus or minus a tenth of a mil. More information on plated metals can be found on the Vishay EFI brand page through the Vishay website. Thank you. Vishay Specialty Thin Film Division presents the benefits and design rules of the filled via technology. Filled vias are an alternative to plated through holes, where the drilled hole is completely filled and then planarized. Vishay Specialty Thin Film offers pure gold filled vias, copper filled vias, and polyimide filled vias. Why filled vias? Filled vias offer a low inductance, low resistance, microwave grounding path through the substrate. They create a thermal path for high-powered devices and temperature-critical applications. Vias provide a two-sided signal interconnection, eliminates epoxy or solder bleed-through during assembly, and reduces assembly costs and reduces piece part count by eliminating the need to mount active die to the package floor. Vishay EFI's gold-filled vias are produced through a plated process, resulting in a pure gold fill material. Gold-filled vias have the conductivity of the bulk metal because unlike thick film vias, they do not contain any frit or binders. They provide superior electrical and thermal paths. Vishay UltraSource's Ultra Via is a pure gold-filled via that is directly bonded to the ceramic hole. Ultra Vias are space qualified. The Ultra Via also is highly conductive and has an extremely reliable electrical and thermal path. The copper filled via is a pure copper filled material that is directly bonded to the ceramic via. The copper filled via is also highly conductive but can be lower in cost than the pure gold options. However, it is not compatible with all metal systems. The poly via is a filled via that is filled with polyimide rather than pure metal. The purpose of the poly via is to be used in the plated through hole designs in order to stop epoxy or solder bleed through during assembly operations. The poly via exhibits excellent adhesion and thermal stability to gold and other thin film metals. The poly via is a much lower cost option for applications only looking to stop epoxy or solder bleed through. The first step in incorporating vias into the substrate design is choosing the via diameter. The proper via size is dependent upon the desired substrate material and substrate thickness. For Vishay, the allowed ratio range is from a minimum of 0.6 times the substrate thickness to a maximum of 1.5 times the substrate thickness. The second step of designing with vias is the via layout. Vias must be spaced apart from each other a distance of 2 times the via diameter from center to center. Vias must be a minimum of 2.5 mils away from the circuit's edge. Each via needs a capture pad, or annular ring, that is at least 2.5 mils larger per side than the via's diameter. Also, if a via vent is required, the via vent edge to pattern edge must be at least 4 mils. The third step is the via modeling. A via hole in a custom substrate can be viewed as a series RL circuit with the resistance and inductance values being a function of via metallurgy and geometry. The via height and diameter are determining parameters when designing circuits. More information on filled vias can be found on the Vishay website. Thank you. Vishay Specialty Thin Film Division presents the benefits and design rules of sputtered gold tin on custom thin film submounts. Vishay electro-films provides a gold tin sputtered eutectic alloy that is used for precise component placement. Vishay electro-films gold tin replaces the need for a preform, and the thinner film provides better thermal transfer than traditional solders. Vishay electro-films process offers a sputtered thickness range of 4.5 microns to 7 microns with a tolerance of plus or minus 1 micron. Our technology has a reflow temperature of 280 to 285 degrees Celsius. The key benefits of Vishay electro-films gold tin technology includes an 80-20 eutectic gold tin composition, where the eutectic composition does not require an additional gold layer to be added, so there is less processing and less cost. The gold tin composition is controlled to plus or minus 2 weight percentage. Pad size tolerance is plus or minus a half a mil, in which allows for a precise placement. The freeze time is at 120 seconds at 320 degrees Celsius, and there is no solder bleed through. Gold tin pads are used for mounting active dye on custom thin film substrates in the following applications: laser diode submounts, fiber optic pump lasers, optical transmitters, optical receivers, and optical TOSA-ROSA packages. More information on gold tin can be found on the Vishay website. Thank you.
The Vishay electro-films IGBR product family is a thin film, high power back contact resistor. The IGBR is available in 4 case sizes from 0202 to 0808. The back contact design is for low inductance. The IGBR has a single wire bond connection and can handle up to a 6 mil wire. The IGBR is also available up to 4 watt. The IGBR can be used in several different applications. Some industrial applications are IGBT modules, commercial lighting, and power converters. Automotive applications include IGBT modules and inverters. One of the applications of the IGBR resistor is as a gate resistor in an IGBT module. A few of the reasons why gate resistors are needed are that they limit the noise in the gate drive path and they limit peak gate current to protect the driver and output stage. For more details on the properties of the IGBR product family, you can go to www.vishay.com for more information. Thank you.
Every day, you continue a journey. It began with one man and one simple but elemental component, a resistor. Over decades, the journey has taken us into dozens of product sectors and around the world, even beyond. And today, our journey, our story, has become the very foundation of the most compelling and important technologies of our time, defining the age that we live in, touching nearly everyone, everywhere. It's a vast universe of diodes and rectifiers, MOSFETs, power ICs, optoelectronics, inductors, capacitors, and yes, resistors, that we call the DNA of tech. And even though people may not realize it, the work we do breathes life into products that make people safer, make work faster, make things go, create energy, sustain our planet, communicate across the globe, every day. This is the power of Vishay. This is the power of you. This is our journey. This is the DNA of tech.